Hi guys, welcome to Baltic channel. In this video, we are going to talk about the copper prices. LME or the London Metal Exchange is the copper price benchmark. So be aware that the copper is majorly used commodity in electrification or in the automobiles or in the construction industry or in the cooking utensils or heating coil or the cooling coils and air conditioners or refrigerators. So there are so many applications like telecommunications and all. You can find copper everywhere, anywhere globally. The price of copper is affected by various macroeconomic factors like the food prices or the ocean freights or the demand of copper or the copper productions, even the US inflation rate or the currency fluctuation. There are so many things which could affect the copper prices. So now what we are going to do in this video is we are going to simulate the price of copper considering various macroeconomic factors. For example, here we have considered four different factors here. For example, the Fed rate, which is the Federal Reserve interest rate of United States, then USD CNY, which is the Chinese currency of USD, you know, currency value or the US inflation rate on a monthly basis, then the Baltic Dry Index, which is the ocean freight benchmark. So these four are the different macroeconomic factors. For example, if the USDC NY currently it is around 7.1, so if it drops down to 6.5, then the copper price could go up to 8,400. Similar, the Baltic Index drop down to 2,000. So you can say it will be around 7,600 approx. So that means each and every factor has some impact on the copper price. So this is a simulation which we have created. Now in this video, we are going to show you how to create this simulation. Just for creating the simulation, we have collected the monthly data starting from January 2017 to September 2022. This is the monthly data. So you can collect the data even for the past 10 years, 15 years, whatever you can. You can collect those data. The first is the copper LME cash settlement price, the monthly average, then what is the Federal Reserve interest rate on a monthly basis, then the crude prices, then the coking coal, then USD CNY, China being the major consumer of copper, as well as the refined copper production is also majorly dependent on China. Then next thing is Chile being the number one copper mine producer, so that's why we are considering their currency. Then euro, since it is being used by multiple countries in the European region, so we are considering the Euro USD currency pair also. Then comes the US inflation rate percentage. Then mine production, global mine production in million tons, followed by the refined metal production in million tons, and global demand of copper in million tons. Then the Baltic Dry Index, which is the ocean freight index, globally it is being followed. Then the natural gas prices per MMBTU. So here we have made some assumptions or forecast, which you can say. So we thought that since the data of September 22 inflation data has not been released, we assume that it may be around 8% in the upcoming days. Then we have used Excel forecast for the other three parameters, since we have the data only up to July. So for August and September, we have used the Excel forecasting under data. You can see the forecast. If you want to know more about it, we have already posted a video on Excel forecasting. We have given the link in the description of this video, you can watch that to understand better about how to forecast using Excel. So that means for simulating the price of copper, we have collected the data for 12 major macroeconomic parameters covering the forex, energy, the supply and demand, and the ocean freight, all these, different parameters we have considered. So now moving ahead, what we are going to do is we are going to do the correlation analysis first. So what is correlation analysis? So for the doing with Excel, go to data, under the data analysis, select correlation, click OK. Then you have to select the data range, leaving the copper. I am selecting the other 12 parameters and make sure that this label in first row is tick marked because the first row the labels of different parameters are provided. So on that also, then click OK. See, this is the correlation table. We have already posted a video on correlation and we have explained it in detail in that video. We have used uh, Google Colab Python for correlation analysis. So we have given the link uh, in the description of this video. You can go and watch that too if you want to understand the correlation better. So, in the brief, I will tell you here if there is any negative sign means it is negatively correlated. This parameter and this Fed rate and the coking coal, these are negatively correlated. Sorry. Then, if it is a positive value, then this is a positively correlated. This 0.69 is, you can see 69 percentage can consider this can be a probability, you can say. So we are going to highlight only the values which are above 0.8. So here there are two values which is above 0.8. So that means, for example, if I'm considering, so if the Brent crude futures value is increasing, if the price of the Brent crude is increasing, then the US inflation rate is also increasing. If the coking coal price is increasing, then similarly, US inflation rate is also increasing. That means any of one value is increasing has a direct impact or a positive corresponding impact on the other variable as well. Similarly, in case of copper production, the mine production is correlated with the refined metal production. It is logical. Similarly, the global demand is also has a direct correlation with the refined metal production. So that means these three parameters are almost related to each other. So there are cases that 77%, 72%, some people used to consider that also, but I'm not considering in this case because I'm considering only and made a benchmark that I will consider only 0.8 and above. So what we are going to do is we are going to eliminate some of the parameters for building the model. Why? Because already the impact of those two parameters can be explained by US inflation. This is on higher side. This value also probably on the higher side. Similarly, the refined metal production is 80% correlated with both the other copper supply and demand related values. So we will be considering refined metal production and we will be eliminating the mine production and the global demand because the refined metal and able to explain whatever the changes or the impact it can produce on the copper prices. So we are going to eliminate these four parameters for the model building. So now we are going to select the model data. just pasting these data as already decided and deleting the current crude and cooking coal. Similarly, mine production is not required and global demand is not required. So the remaining parameters I am keeping it. So now what we are going to do? We are going to build the model. What is that model? Now I'll show. Go to data and go to data analysis again. Now in that we have to select regression. Click OK. Now to select what is the Y. Y is the output. So here the copper price is what we are going to predict, or this is the output what we want. The input is the remaining other variables which are impacting the copper prices. I have selected that. Make sure that labels is ticked since the first row belongs to the labels, and click OK. So this is model 1. So now here, before going ahead, we have to first check the p-value. So wherever the p-value is above 0.05, you just highlight those. This one. The next thing is the refined metal production, Euro USD, then USD CLP, actually peso. Then other values are less than 0.05. So in general, if any parameters or any variable is more than 0.05, then it is not significant. But that means it is not making a major impact on the, here in this case, it is the copper price. It is not making a major impact. If you want to know or understand better about the p-value, I have already discussed about this in hypothesis testing video. I have given the link in the description. You can watch and understand in a better way. So now in a brief, I will tell. So whatever the value variable having the p-value of 0.05 or less than that only, we are going to consider. So that means we have to build a model eliminating these 4 variables. That means this one, the first one is USD CLP, Euro USD. These 2 parameters are removed since it is not making an impact. Then refined metal production, the refined copper production is also not required. Then the natural gas is also not making any impact. So now what we are going to do, we are going to build model 2. Again, follow the same procedure, go to data analysis, regression, click OK. The first one is already selected to copper, then the second one, now we have to change this to only 4 variables. Make sure that the input range is continuous. So if there should not be any empty column, there should not be any column which data is not required. It should be continuous. You can't use comma, then you are selecting the other one. Those things are not possible in case of regression. It makes sense. So now these 4 parameters. Now you can see all these values. The p-value is very much lower than 0.05. In the confidence level, here in this case, it is more than 99% also. You can see not even 0.01 because e power minus. So it is almost 100%. You can believe this. You can say those parameters are impacting the copper prices. And another one thing what we have to check is the adjusted R square value. What it tells means how much valid this model is. So you can see this how much this model can able to explain the variation in copper. You can say it is 0.916, which is around which is 91.69 or 92%. This model can able to explain the changes in copper prices. It's 92% this model can able to explain. So, generated. So now this is the final model we are going to use in our simulation. For that, what I'm going to do is I'm going to insert a worksheet. Sim one. So what are the parameters? Here there are four parameters. These are the four parameters. Then here the important thing is the coefficient. Copy paste, even consider the intercept also. Copy paste the coefficient also. Now here in this column is what we are going to mention the interest rate, like 3% for example. USD CNY is around 6.8, the inflation rate of around 7%, the Baltic Index is around 1700. So now the simulated copper price. So how to do this is just some product of this values, comma, this values. Just do the sum product, then plus this intercept has to be added to it. I'm fixing that also. So now see, if the Fed rate is 3% and 6.8, considering these macroeconomic factors, since these are highly significant variables. So considering these four highly significant variables, you can say this is the simulated copper price. In case, so there are expectation that the by this year end, by that is by the December 22, the Fed rate could reach up to 4%. So, and similarly, we feel if the US inflation dropped down to 6%, and similarly, if it is going to be 7, so by changing the value, you can see this value is getting changed. That means, so if the Fed rate is increasing, you can see there is a negative impact, which means the copper price is dropping down. If the Fed rate is reducing, then the copper price is increasing. Similarly, if the Chinese currency gets strengthened from 7 to 6.5, you can see the impact on copper price. So I'm just changing 6.6. Just see the copper price from 7,500 to it's almost 76.90. And similarly, the inflation rate, if it drops down, the copper price again going down. Then the Baltic Index, which is the ocean freight, you can see if it becomes 2,000 or if it becomes 5,000 also. See, if it becomes 5,000, you can see what is the impact, what impact the Baltic Index or the ocean freight could make on the copper prices. So as a procurement manager, it is very important how each and every macroeconomic factor is affecting a commodity price. So using this model, we we can able to find what could be if the inflation rate reaches to 4%, what could be the price of copper price? And further, we want to show you one more thing also. What could be the error using this model? So that also we will show you. So what we are going to do is we are going to predict price. We are going to calculate the predicted price. What it is, simple. Fed rate multiplied by the Fed rate coefficient. Fix that value plus USD multiplied by USD coefficient plus third one is the inflation rate multiplied by coefficient of inflation rate plus the Baltic Index multiplied by the Baltic Index coefficient. After doing that, you have to add the intercept. So this is the predicted value. To fix this, error, then the error percentage, if we are calculating this value, is what is the actual divided by this month it is 7%, the absolute error. So use ABS, so 7% is the error. I'm just copy pasting it, but mean average percentage error, what it could be. Average of all this value, which is around 5%, which is 4.69 or 4.7% is the error across the different months in predicting. So here how we can use in this case is lower level, the upper level. What we are going to do is, in case of lower level is plus, so sorry, minus this to this. In this case is going to be plus this to this. So the tentatively we can say with this inputs, so we can hide this also. We need to show. So with these inputs, if the Baltic index is going to be, it's right now it's near to 2000 probably. So with these parameters, you can say the copper price has to be in this range. So that means we can take a decision also using this simulation, or if we read a news, for example, the target of US inflation is 2%. If it goes to that level, what it could happen to the copper prices? So it will drop down to 6,000. Meanwhile, the inflation rate in those scenarios may not remain at 4%. It also may come down to 2%. Then you can say it will come to your to 7,000 level, 6,500 to 7,000 level. It may drop down to 0.25 percentage also in those scenario. The copper price increased. Similarly, the CNY, if it strengthens more, and you can see it increases further. So that means each and everything, any change in this macroeconomic parameters are affecting the copper price. So in this video, we have explained you how to simulate the price of so this is a simple method we have explained you using Excel regression model. You can use Python or or for getting a better model, because that may come up with a better model, limiting the error percentage further, you may get a better result or a simulation. But most of us, we use Excel, so that's why we have built this model using Excel, and we have shown this simple simulation. It will be helpful for everyone. So you have learned something new. Please share this video with your friends or relatives who are working in the commodities. So this video will be very helpful to them for to understand the macroeconomic factors and its impact on the commodity pricing. So if you have any queries, please put it in the comment box. We will reply to you. If you want us to post some videos related to data analysis or related to supply chain, just post us. We will try to come those videos based on suggestions. Thank you for watching.